Hello everyone. So in the previous video we had done property 4. Now we'll do property 5. Here it says if the elements of any row or column of a determinant are multiplied in order by the cofactors of the corresponding elements of any other row or column, then the sum of the products thus obtained is 0. Here I have tried to explain in general, but I will not read this straight. I'll jump to example. Okay, so let me take one example. Here this is the example. Now what the statement is trying to say is, suppose I take the elements of first row. Okay, so in that case this one will be multiplied to any cofactor. Okay, either cofactor of this or this. Okay, let's say one is multiplied to cofactor of this 0. Okay, let me denote this by C2. Okay, and then plus, then this 2 will be multiplied to cofactor of this one. Okay, since we are taking cofactor of the second row. Okay, so cofactor of this, let's say this is okay, and then I will take 3. Okay, and then this 3 will get multiplied to cofactor of this. Okay, so answer will be 0 in that case. Okay, even if you would have done this way, this take 1 and multiply this one with the cofactor of this one. Okay, take this 2, multiply with the cofactor of this, take 3 and multiply with cofactor of this, then answer will be 0. Okay, so this is what they were trying to say, that if the elements of any row, like here any row we had chosen as first row, of a determinant are multiplied in order by the cofactors of the corresponding any other row. So in first I had taken row 2 and in second I had taken row 3. Okay, then the sum of the products thus obtained is 0. Okay, so this is what they are trying to say, that okay, so if you, let's say you have chosen row 1, then what you do for 1, okay, corresponding elements cofactor in other row. Okay, any other row. So let's say we have decided to take row 2. Okay, so corresponding cofactor for 1 in row 2 will be cofactor of 0. Okay, for 2 cofactor of this, and we'll multiply them. Okay, we'll take sum, then will come 0. Okay, so let us see. Cofactor of 0. Okay, for R2. Okay, for R2 cofactor of, let's say 0 will be equal to, so you have to recall that sign, plus minus plus minus plus minus plus minus plus. So we are looking for this element, means minus I have to put over here. Done. And then forget the column, forget the row. Okay, so you will get 2 3 1 1, so you will get this 2 1 are 2 and minus 3, so you'll get minus 1, so it will be 1. Okay, and then cofactor of this one. Okay, so in that case we have to write plus, so no need to write. Then forget the column, forget the row, you get 1 3 0 1, so you get simply 1 over here. Okay, and then cofactor of minus 1. Okay, so here sign should be minus, so put minus, then forget the third column, forget the second row, so you get 1 2 0 1. Okay, so this will come minus 1. Done. Now see, Now what will happen from the first row? Okay, 1 into, okay, cofactor of this 0 will be 1, then plus, okay, then you take 2 down, then into cofactor of the corresponding one, so that is 1. Here you can see 1, then plus, then take 3, okay, so 3 into cofactor of this, so you get -1. You can see that 1 plus 2 3 and -3 is 0. Yes, it's coming. You same way you can find cofactor of this 0 1 1, and you can try, you'll get 0. Okay, now what I will do is I will do for columns. Okay, means what I'm trying to say is, let's say, okay, let me write the question again. So delta is there, 1 sorry 1 2 3 0 1 -1 0 1 1. Now let's say I have chosen this column. Okay, then what I have to do, each element of this column should be multiplied to cofactor of its corresponding element of other column. Means if I am taking 2, then either like suppose I choose column 2, then I will take cofactor of 1 and multiply to 2. Then for this one I will take cofactor of 0 and multiply to this. Okay, then I will take this one and I'll take cofactor of this 0 and multiply. Okay, in that case also I'll get 0. Okay, so let's do for, let's say I'm doing for column 3. Okay, for C3. Okay, so you should remember plus minus plus minus plus minus plus minus plus. So I'm doing along sorry, I'm finding cofactors for these elements. Okay, so I have to use this sign pattern. Okay, so cofactor, so cofactor of 3. So here you can see plus we have to use, so simply leave it. Then forget the first row, third column, then you get 0 1 0 1. This will be 0. Then cofactor of -1, sign has to be used, minus, done. Forget the second row, forget the third column, you get 1 2 0 1. So you will get 1, that will be -1, and then cofactor of 1, so plus sign. So forget this third row, forget this third column, you are left with 1 2 0 1. So again you get, oh sorry, this time you get +1. Done. Now what we will do is, now since we have chosen the first column, sorry, this is your second column we had chosen, I was saying first column, so second column, so I'll take 2 corresponding to this is 3, so cofactor of 3 is 0, then plus, then I will take 1 corresponding to this, it's -1, cofactor of this is -1 only, -1 into -1, then plus, then I will take this one, sorry, this one into cofactor of corresponding, so minus cofactor for -1 is -1, then plus, then I will take 1 cofactor for corresponding, this is 1. So here if you see 2 into 0 0, -1 plus 1 0. Okay, so this is what this statement is trying to say. Okay, so this is all about property 5. Now we'll see property 6. So property 6 says if each element of any row or column is the sum of two numbers, then the determinant can be expressed as the sum of two determinants whose other rows or columns are not altered. Okay, so it's trying to say that if you have something like this on the left hand side, then you can write like this. Okay, so here if you see in the first row, this element is sum of a1 and alpha 1. This term is sum of b1 alpha 2. This is sum of c1 and alpha 3. So you can write it in this way. Okay, for example, if we have like this 7 4 10 1 2 3 0 1 1, so you can see that 7 can be written as 2 plus 5, 4 can be written as 2 plus 2, okay, 1 plus 9, whichever way you can write. Okay, so here I saw that in the first row these terms are written as sum of two numbers, so I can write like this: 2 2 1 1 2 3 0 1 1, okay, plus 5 2 9 1 2 3 0 1 1. Done. So basically they are trying to say this. Okay, so if each element of any row is the sum of two numbers, then the determinant can be expressed as the sum of two determinants whose other rows or columns are not altered. Okay.